Okay, in this tutorial I'm going to take you guys through creating this bookshelf. So we're going to start in Fusion 360 by creating some parameters. We're going to set up a sketch. We'll create a full 3D model and then show you how to take that 3D model and prepare it for manufacturing by laying all the parts out, putting on some dog bone fillets, setting up your cam to create G-code, simulating that, ultimately loading it all up into the ShopBot, cutting it out, and finishing it up and creating the final product. So let's get started. So here in Fusion, when you start up, you're always in a new design. If you want to create a new design, you click File, New Design, and now you're in a completely empty project or part or assembly or whatever you want to call it. And before we do anything, for a project like this, what I first want to do is I want to create some parameters. So I'm going to create some parameters by pressing the little green checkbox. For example, the first one and most important is the ply thickness. So let's say I've measured that exactly at 0.725. We want to put this in, and we're going to use this all over the place so that as I develop the design, I'm always referencing this one parameter of ply. So if I go to rerun the job and I measure at 0.735 or whatever, for each time I cut a new piece of material, I can adjust this one number here, and all of the pockets and tabs and heights and everything else are going to all adjust to accommodate the exact ply thickness that I've defined. I can also use this to define overall things, like if I wanted to make a configurable bookshelf. Let's say we wanted the height to be 26 inches and we want to create a width of 30 or a depth of 14, etc. I can keep creating these parameters and I'm going to use them all over the place. So fast forward, here I've created all of these parameters. So you can see I've defined a width, a height, a depth for the overall bookshelf, the ply thickness. I've also defined the cutter diameter I'm going to use. So this way I can change this cutter diameter, and if I do things like create dog bone fillets later, the diameter of those is going to be referenced to the size cutter I'm using. So it's nice to be able to reference this here. Some things I didn't even end up using, like this tall. If I wanted to put a tolerance gap somewhere, I could be referencing that. Things like shelf kick, the tab width. Also something here like a blind tab where I don't want to go all the way through the material. I'm going to say only go about 60% of the way through the material. So these are the types of things that you create these parameters, and then we're going to use them as we go work on this design. Okay, so the first thing we want to do in this design is going to be to create a sketch to represent the profile of the bookshelf. So I'm going to say sketch, create sketch. I'm going to sketch on the side profile face, and then we'll come in and start by creating a rectangle, and we'll draw this just some arbitrary shape, and then we can give it a dimension. So here we're going to leverage those parameters we created. So instead of typing in a number, I'm going to type in the word height, and then it's going to show me what that value is. Same here, depth. Now I can come in and create some more rectangles, and these are going to define the different pieces. So like the top will have a shelf, we'll have a bottom shelf, have a little kick plate here, and then we'll have a piece along the back. And now it's just a matter of creating some more dimensions to define the sizes. So the thickness of all of these is going to be ply. And this is one of the real advantages, is by adding this parameter all over the place. So we'll create these dimensions of ply, and then once you actually are ready to cut this and you go in and you measure your material very precisely, you just have to go in and change that parameter for ply, and then all of this will update, and then all your thicknesses and everything else will be all up to date. Same if you decide you want to change the design. We're going to just type in the word kick here. Again, we'll do up to here. We change this. This is called shelf. So if you ever want to change some of this stuff, you can just modify those parameters. If you do want to use a specific value, for example, like this, maybe you just know that no matter what, that's always going to be fixed. We just always want that to be 1 inch. You can type in a regular number at any time in these dimensions as well. And now you've got your overall sketch profile defined. Now that I have this sketch done, this is going to kind of outlines all of the parts in the bookshelf. Now what I want to do is start creating individual components. So to do that, I'm going to create an extrude, and then I want to pick the sections of this sketch for the given part. So in this case, I'm going to start by creating the top. So that's going to be that profile and that. So you should pick 2 things, and you can either just start dragging this out, but in our case we want to extrude this a specific value, and that is width. So that's going to be, again, a place where we're leveraging those parameters. So you can do that here in the extrude commands as well. And when I do that, it's going to hide the sketch by default. So if you want to do something more with that sketch, you can always come back over here to your tree. In sketches, you'll see sketch 1. You can show that, and we'll do it again because we want to create another piece here. So again, I'm going to say extrude, and here I'm going to create the side piece. Now this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 sections. So again, this side represents all of those sections. So you just need to make sure that you grab all the sections, and we want to say new body, and for the distance here, this is where we're going to use that ply parameter to use our material thickness. And again, make sure the operation is set to new body. That's very important. And we'll say OK. And then we can hide this sketch if we don't need it right now. Okay, now rather than re-sketch this, what I can do is I can just take this side piece and mirror it. So to do that, the first thing I need is a plane to mirror about. So we're going to use construct, and we're going to create what's called a midplane. What you do here is you basically pick, say, something like this face, and then that is going to create a midplane right between it. So you can turn off all of your construction, or you can turn on and off this plane here. That is going to be a plane that I'm going to use quite a bit through the rest of this design. And now create, mirror. I'm going to mirror. You want to select bodies in this case. So our pattern type is bodies, and our mirror plane is this one. And we've picked this body to mirror, and now we've got that part. So that's going to be a technique that I use throughout this, which is to basically create one body and then mirror it across this center plane to leverage it over on the other side. So the next thing I need to do is to create the shelves and the back piece that are going to go from this inside face to the other inside face. So to start features that start from this inside face instead of from where we originally sketched it. So if you look, that sketch is actually on the outside, and we want to create some features from the inside. The easiest way to do this is to quickly create a new sketch on this inside face, and then let's just hide some of this stuff for a second. And I'm going to use the geometry from the first sketch, so project, include. So what you're doing here is you're basically saying I want to just grab a reference to all of these lines from the first sketch. That way if anything changes in the first one, it'll be updated here. And then we're going to use this new sketch to create some parts. Okay, so now we're going to use that sketch to create the rest of the components. So again, create an extrude, and here, rather than specifying a value, we're going to say we want to go up to the inside face there. That way you don't even have to worry about figuring out what that depth is supposed to be. And instead of join, again, we want to use new body. And now we've created the back. Now we'll go ahead and just repeat that process. So create, extrude, and we'll pick this, which is our bottom shelf. And we will say we want to go up to this inside face, and it will be a new body. You can right click and drag up to repeat a command, which is kind of nice sometimes. So do that, say new body up to that face. And then again, down here, you can see the kick plate, and we'll go to that inside face. That looks good. And remember to always set it to new body, and we'll hit OK. Now you can hide that sketch. Another thing that's nice to do here at this point is I'm going to apply an appearance. So again, I right click appearance, and you can browse into wood. So you can see here I've got into wood finished, and I've got oak glossy, oak semi-gloss. Let's use oak semi-gloss. That looks pretty good. And you just can drag this out onto your parts. Obviously this isn't a necessary step, but it looks pretty good when you're modeling and you're kind of looking at it the way it's going to look. I like it. So now that we have the basic parts, I want to create some tabs so that we can create the press fit joints between all of these components. So I'm going to hide all of the parts except for the kick plate, and you do this easily by selecting on the light bulbs here in the tree. Now I've got the kick, and I want to create a new sketch. I'm going to create a sketch on the front face here. I'm going to go and grab my 2-point rectangle tool, and we'll just draw these two tabs in kind of at a rough shape, and then we can go get dimension tool. So here I want the depth of this to be ply, so it's the ply thickness. Here's a nice thing we can do too, which is I can say, okay, I know that I have a parameter defined called kick, but I want this to be kick divided by 3. And then the same here. So we'll make the tab 1/3 of the depth. So if you change that kick parameter, this will all update. Over here, also ply and tab. And another thing we can do that I use a lot is I'm going to create a quick construction line. So I'll create a line that just goes from that midpoint. You'll know you have the midpoint when you see that triangle. You can select the line, right click, say you want to make it construction. That way it's really just there for reference. And now I can quickly create a dimension from the origin, which remember this is going to represent the actual edge of the bookcase. This is inset by the thickness of the side. So we want to go from here to the center, and then we want this to be equal to the overall bookcase width over 3. And that should put us right where we want to be. Now we can use that sketch that we just created to create the tab. So I'm going to create an extrude, and we pick the two profiles. And here what I want to do is again use the extents. I want to set this to be 2. I'm going to go up to that back face. And we'll go ahead and leave that as a join just so we can show one way of doing this, which is to use that as a join, and then I'm going to go ahead and create a mirror. And there's different choices here. I can either mirror faces or bodies. Next I'll show bodies, but in this step let's use faces just so you can see the difference. So with faces, what I need to do is pick all of the faces of the component that I want to mirror. So a little more steps. So I'll pick those 3 faces, and then for the mirror plane, again we'll use that mirror plane that we created, and we get the result that we're looking for. Okay, so now let's create a sketch for the tabs on this shelf. So sketch, create sketch, I'm going to pick this face, and now we're going to create just the tabs on one side. And again, we'll create a lines for the midpoint. I do this because it gives me like a nice way to create a dimension to the midpoint of these rectangles. They don't really have to be straight or anything. And then what you want to do is pick them, right click, construction. Now those are just kind of some reference lines to give you that reference point at the center. It's not necessary, but I just do it out of habit. Now we'll create some dimensions. So we can again leverage our parameters. So the width is going to be tab, 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 and then the height of all of these tabs is going to be equal to the thickness of our ply. Now again, remember the point of this is that if I was to, after I measured my actual material thickness and I go modify that parameter ply, all of these tabs are going to adjust as well. So you're always going to have a nice perfect fit when you do it this way. And we'll also take advantage of our other parameters here. So this is going to be depth over 3. This one will be depth over 3. And then here again, you want to make sure you're going from the edge over to the center of that, not from the edge of the shelf. And we'll call this one width over 3. And that should give us the sketch that we need to create these 3 tabs. Now we can create an extrude for these tabs. So grab the tabs, again, distance up to that face. But again, we want to make these new bodies because we're going to really leverage just creating these 3 and then mirroring them around. So we'll take those 3, then we'll create a mirror of them. So grab the 3 bodies and we'll mirror them around our construction plane here. Now we've got these up, let's go ahead and leverage that for the shelf as well. Since we want the same exact tab pattern on that shelf, again, the first thing I'll do is I'll just quickly create a midplane between that face and that face. And that gives me this plane here. You can turn these on if you want. And then we can create a mirror, and this time we'll grab all 6 of these and then mirror it about that new midplane that I just created. Say OK. Turn the view of that off. Again, light bulbs turn things on and off. And I'm going to use my combine feature. So set the target, and then all of these are the tools. Join, don't want to keep the tools. And now we've got that part that we want, and do the same thing here. So again, this is why I like to make these tabs as individual bodies. And sometimes it's really just super convenient to mirror them around, copy them, and then combine them later. It just saves you a lot of work in the long run. Okay, let's create the sketch for the tabs on the back. So again, we'll create the sketch. We'll do that here. Sometimes you might want to rotate around so you're looking at this from the front so that you have the right perspective. And we'll create our rectangles. So I just kind of draw these in arbitrary place to start with, and then make my reference to the midpoint just to make it easier to dimension later. And then we'll make these construction. So right click, construction, and now we'll create dimensions. So again, we're going to leverage all of those parameters. So the width of tab for all of these. And then the depth on these sides is ply, so we want to just have that go all the way through the thickness of our material. And then on the top, this is going to go into one of the blind pockets, so we'll call this one blind tab. And then for the position, we'll go from here to the center. We want that to be height over 3. Center to center will also be height over 3. And then here, we just want to measure from the actual 0 point, not from this inside edge. We really want the outside edge of the whole bookshelf to this point to be width over 3. And there we go. Alright, again, just take these, create an extrude of the 3 tabs to the inside face, create new body. This way we can, again, mirror those 3 tabs about that initial mirror plane, and then do the combine. There we go. Okay, so let's create a sketch for the tabs on the top of the side. So create a sketch on this face back here. We'll create 2 rectangles. And again, we'll create dimensions. So we'll create all of the dimensions that we need. And this is going to be depth over 3. And then we'll just create the rest of the dimensions real quick. So now you can see there's a little bit of a problem where we've got the tabs coming right to the edge of the top piece, so we really need to make a little bit of a lip to be able to have room for a pocket. So rather than try to refigure out where that could be in the design, changing sketch planes or anything like that, all I'm going to do is come in here and say modify, press pull, and now I can just grab these faces, pull them out. We'll just go like a 1/2 inch, and that'll just give me a little bit of a lip to create room for a pocket. You can repeat that. Grab this face, move it out 1/2 inch, and then the same thing over here. And now we've got a nice design. Note that the width and the depth now would be off, so the width would be actually 1 inch longer than we've originally defined. If you want, you could go back and modify the parameters, make a different equation, whatever. For now, I'm just going to leave it. Now we want to create the cutouts for all of these tabs. We're going to do that with the combine feature. So with combine, I can pick the part that I want to cut. The tool is going to be this kick. So basically I'm going to use the tabs in the kick to cut the pockets out of this bottom shelf. And we're going to say keep tools because we want to keep the part after it's done. Again, repeating that, combine. Let's say we want to cut out the back, and the back has pockets for the 2 shelves tabs. So the 2 shelves are going to cut the back. Do it again. Now we're going to cut, if we want to cut one of these sides. So we're going to cut the side, and all the parts that we need to use to cut the side that have tabs that intersect it are all of these. So say OK. Can repeat that again. Cut the right side, and again we'll pick all of the parts that are going to cut it, and then finally one more time pick the top, and we'll cut that with this part, and this part. So now, for example, if you look at one of these, if we were to hide some of these parts, you can see now that the sides have all of the pockets cut out. Now that the model's done, what I need to do is lay these parts out flat. Before I do that, one thing I like to do is to just quickly create something that's going to represent the stock. So if I do that, I'll go ahead and pick this plane, and I'm just going to sketch out a rectangle. So I'm creating a box feature, and we'll make this 96 by 48. And then for the height, we'll give it that value of ply, and then we'll say we want to create a new body. And what this is going to do is just give me that reference piece to line everything up against. Now I want to take all of these parts and lay them flat. So before I do that, right now we've been modeling as bodies, and what I want to do is I want to take all of these components, bodies, and I want to make them into components, which is a distinction in Fusion. So I'm going to select all the bodies from the tree, right click, create components, and now I could come in here and rename them. Now that we have components, what we want to do is we want to create joints. I like this just because it makes it really easy to move things around and lay it out in a flat pattern the way you want. It's not a totally necessary step, but I just think it's a pretty quick and easy way to do it. So the first thing we're going to do is we're going to take this stock, right click, and say we want to ground it. That's going to basically fix that one piece. Now we're going to come in and create a joint, and what we'll do is we'll pick the face that we want to line up. So that face on the top, and then we'll match that to this face on the stock, and we can set the type to be planar and then flip it, and now it's essentially lined up with the stock. And then what's nice about that is then I can take it and I can just drag it around and it'll stay in that plane, so we can get things oriented the way that we want. Okay, now what I like to do is to just to make it easier is to just hide the one and then create the joints for all the others. So I'm going to hide this from the tree, and now we'll go ahead and start creating all of the rest of the joints. Now that we've applied all the joints, we can just drag these things around in the plane. One thing that makes that a little easier is you can right click on the stock and make it selectable, unselectable. If you do that, you see the little red crossed out circle. That means that it's not going to be selectable, which makes it easier to just pick all of these parts without that getting in the way. And you can just grab all these the parts from the bookshelf and drag them around to lay them out on the sheet. If you want to do something more, if I want to rotate it, I can actually, the best thing to do is to pick it from the tree. That way you have the component selected, and then hit right click and say move. And now you can do things like rotate it, and you'll notice that it snaps to 90. You can still drag it around while you're in this command, and then hit OK. And then maybe the last one I want to do is take this guy, and again I'll grab this and say move, and we'll go ahead and rotate this one as well, and then move it into place. And now I've got all the parts laid out flat the way that I want. Now that we've got this all laid out, what I want to do is apply Dogbone fillets to all of these internal edges. So we've got a nice little add-in that somebody wrote, Casey Rogers, which allows you to create dog bone fillets, and we can either apply this to each edge individually, so I could pick all these edges, or you can actually just pick the bodies, and if you pick a body, it's going to find all of the vertical edges that are inside corners and apply it to all the edges. Another thing we're going to do here is just put in our parameter of cutter. This way, if I change my mind about what cutter size I want to use, it will adjust the dog bones accordingly, and we'll just go ahead and hit OK. And this is going to take a couple of minutes to process, so just be patient if you're processing like this with 150 something edges. Just be patient. And here we can see the result of the dog bone fillets being applied to all of the internal corners. Pretty nice. Okay, the last thing I want to do is create a little bit of clearance in these pockets for the blind tabs. They're currently modeled exactly flush. So I'm going to do a press pull, and then I'm going to pick all of these faces, and then we're just going to offset them down just a little bit. So you see I can just drag this as much as I want. We want to make sure you do a minus 0.04, whatever clearance you want, but the important thing is to put in the minus sign so that you know it's going in that direction. Okay, so now that we've got this all set up, the thing that we've got to do is now create toolpaths. So I'm going to switch over to the cam module, and now we can start creating it. So what I want to do is create a new setup. So setup, new setup. And the first thing we're going to do is define our origin. So we want to set the direction of X. So I do that by clicking on the back half. Notice you can pick the back half or the front half of these arrows. Click the back half of the arrow and give it something to reference just to get the direction oriented. And then I'll click the front half to switch it. Then I can click on this point right here and say I want to align it to the lower left corner of my stock. Another thing that you should do is select on model. This way we're just going to define exactly what parts we're cutting out. Maybe you have some extra bodies, extra parts, that reference model of the stock, things like that that you don't necessarily need to be computing toolpaths for. We just want to do it for this. So we've selected our models. Now we're going to go over to our stock and we're going to give it a specific size. So we know that this is 96 by 48. And then the height, again, this is the other place. So you need to change it over in the model on that ply parameter. And then here in height, we need to set it as well. So here we're going to set it to something that we measure. So again, you want to measure your stock very precisely and then input it here. And this is just another small thing. You want to say offset from the bottom in -Z0. As long as this and your ply parameter were the same, it wouldn't matter, but it's still good practice, I think, we've noticed. So we'll do that, and now we've got kind of the base setup for where is my origin point and how is my stock defined. One thing I like to do is to just kind of name the setup with the tool I'm going to use. So I know this is going to be for a ShopBot, and it's going to be I'm going to use a 3/8 compression end mill. So that just way, if I'm going to use multiple tools, what I'll do is I'll create a setup for each tool, and then all the operations for that tool will go into one setup. It makes it really easy to post it out in groups and then just run one program at a time on the ShopBot. I just like to run one program for each tool, do the tool change, then run the next program. For me, that's what's been working really well. So now I'm going to go ahead and create the first operation. The first operation is going to be to create a 2D pocket. And we'll do that here. So I'm going to create a 2D pocket to cut out all those blind pockets. We'll pick a tool. In this case, I'm not really worried about getting the exact parameters of the tool, just because I just want a generic, kind of a generic 3/8 cutter. Because all I'm really worried about for right now on the router is just getting the tool diameter right. And then I can set some the spindle speed. I can set my feed rate. In this case, I'm going to use 60. And then I could set the lead-in feed rates as well. And it's going to do a little calculation for me and let me know what my feed per tooth or my tooth load is as well, which is kind of nice. For geometry, now what I need to do is pick the exact pockets that I want to cut out. So here, I'm going to pick these pockets. So again, all my blind pockets. Now this happens sometimes. You got to remember, you got to notice with this arrow is on the outside of the pocket. You need to click it and it'll switch the directions, basically saying which, am I going inside or outside on that edge you just picked, and I want to go on the inside. So you need to make sure that on all of these pockets that you pick, that again happened again, you just want to always make sure that you're cutting to the inside of the pocket, not the outside. And we'll get these last two from this part. So remember, there's 6 on the one, and then again, I need to flip this, and 2 on this one. So the first thing I'm going to do is my blind pockets that I want to completely clear out. Okay, heights, we don't really need to change anything here. Under passes, there's a couple things you definitely want to change. We want to do right conventional milling. So climb milling, more for like a very rigid CNC machine, doing high precision metal cutting. The other thing we want to do is a step over. So if you want, you could just step over by the entire tool width, or you could cut this down. It's a personal preference, I believe there. Stock to leave, if we were going to come back and do a finishing operation later, we would maybe want to leave a little bit of stock to cut off if we were doing like a 3D contour thing or something. In this case, we're just profiling out these pockets, so we don't need to leave any stock. But what we do want to do is take multiple depths. So here I'm going to set the step down to be half the cutter diameter, seems to be about the rule of thumb. And then also for a finishing step down, we don't really need to do an extra finishing pass here. So I'll just also set that to be the regular step down that I want. And that way we'll just basically just take steps all the way down to the bottom of the pocket in half the cutter diameter. And then the last thing is over on linking. One thing that I like to do here, ramp. This is how the tool's going to enter the material. And you can see a nice preview of all of these things. You can see a nice preview if you just hover over the the option, you can see what they are, what options you have. So you can see here pre-drill, plunge, helix, etc. So helix is nice if you're trying to enter into a very hard material like aluminum or something. But in this case, we're just going into plywood, so we'll just do a straight plunge, and it just is much faster. And with that, we'll say OK, and we get a preview of the toolpaths. So you can see here what the tool is going to do as it goes from pocket to pocket. So the next thing I want to do is cut all these through pockets. And I'm going to do this by using a 2D contour. So a 2D contour will come down and just cut the profile. So if the cutter was less than half the width of this pocket, then you'd actually end up with a little sliver in the middle, in which case you might want to use a pocket. Doesn't really matter. You could use a pocket here or a contour. Really, it's going to accomplish the same thing in this case. But again, I would say 2D contour, and I've already got it set up here so that you don't have to watch me pick all of the pockets. But again, I'm using the same cutter, set my feeds and speeds. Under the geometry, you can see that I've picked that. What you always want to do is just pick one edge on each profile, and it'll find the profile. And then again, also make sure that the arrow's on the inside of all of these pockets, not the outside, or else you'll end up with the cutter going around the outer profile. So in this case, there's 18 of them. Heights, nothing to change. Passes, same adjustments that you make here that you made on the previous pocket. So I want to definitely say I want to make right conventional milling. I want to set the maximum step down to be half the cutter diameter, and same for the finishing. And then on linking, I just turned off ramp. If you want, you could ramp in. Doesn't matter. It would be maybe nicer if you did a little ramp on the way in. You could say you want to come in at an angle. And you can see the result there of those pockets. So now what I need to do is cut out the actual pieces, the outer profile. So again, I'm going to use a 2D contour to do that. By default, it's picking the last tool I use, which is good for me here. Then for the geometry, I'm going to pick all of the contours. So it's these profiles here. Should zoom in and make sure that these are going in the right direction. So again, some of these were on the wrong side. And here, all good. So now I've selected all the profiles that I want. Now on this one, I want to do something else a little different. I want to add some tabs. So we're going to add tabs to keep the parts from flying off once they're fully cut out. And we can either do rectangular or triangular. I'm going to do a triangle. I'm going to do 3/4 by 0.185, so just under my step height. And I could either say by distance, which would put these every 3 inches on any side that's at least 3 inches long, or I'm going to say by at points. And so in this case, what I can do is I can actually come in and I can just specify, I'll just pick, like say 4 points on each part that I want, where I want to put the tabs at. And this way you can kind of specify it yourself. So fast forward for a second, and then you can see I've picked all of the places for my tabs. So all those white dots represent where a tab is going to be, and like I've just placed them. So in this case, I've got 28.4 per part. Under passes, again, make sure you set it to right, conventional milling, and we're going to have set the depths again, so multiple depths, going half the cutter, and then under linking, just really taking the defaults here as well. And with that, we'll say OK, and now you can see, again, the blue lines represent a preview of the toolpath, and you can kind of zoom in. You can see here the tool is going to take that little jump right there, the little jog to make the tabs. Looks pretty good. Once you've created all the toolpaths, the nice thing to do is to be able to simulate it. So if you select an individual toolpath, you can simulate just the one, or you can select the entire setup folder and press simulate, and you can turn on the stock, which I like to do. And what that's going to do, it's going to let you, it's going to show you actually the material being removed. When you press play, it'll show you the material being removed. You can do things like skip just right to the next operation, so done with the pockets and now it's doing the through pockets. Again, this is like nice to just see what's happening. I've caught many errors by looking at the simulation and realizing the tool is going and cutting somewhere that I didn't expect, or it's cutting the wrong side, or it's not finishing where you thought it was going to be finishing. The other thing you can do is just kind of jump to the end, so after it's done everything, and then you can take a look at what you're going to be left with. So here we can get a nice visual on, you know, where are my tabs? Are they in the right place? Do they look good? Does it look like they're all done? Is there a big chunk of material left in here that I wasn't expecting? All those types of problems that you might find once you're cutting, you can find here in the simulation. And once you're done simulating, same thing. Again, you can either post out an individual operation, or you can post out the entire setup, which is why I like to do one per material, or one per tool. And now I'll pick this, and I will say post process. Here I can select either any post processor. In this case, we have two for ShopBot. One that'll create OpenSBP files, so ShopBot language, and then regular G-code, the ShopBot ISO post. And if you want to go in and adjust here in the properties, if you have some specific properties that you want to adjust for your specific machine, you can change those here. In this case, I'm going to take the default and export this G-code. And we'll overwrite the one that I have, say save it off somewhere where I know where it's going to be, and then, you know, if you're not doing this on the machine that you actually have hooked up to your ShopBot, then you can then just take that, put it on a USB key or whatever, move it over to the machine and load it into the ShopBot controller and run the job. Alright, thank you guys so much. I really appreciate you taking the time to watch this. Please leave comments if you have any questions, and I'll keep an eye on it, and hope you guys enjoyed this, and let me know what you think. Thanks.